Hello, my name is Gasteazoro, and I work as a segment leader for defense at Cummins. Cummins has operated in a highly competitive environment since inception in 1919, right? When we've been successfully able to do so because of actually our ability to effectively innovate for our customers, both end users and OEMs. We are laser focused on engine and power technologies. And as a large global player, we bring large number of resources solely for this purpose, which provides expertise and confidence to our OEMs. We focus really on bringing innovative solutions in the areas that matter to our customers. So for example, we know combat applications have a continuously evolving need for higher power density level out of any engines that they use or in any vehicles. The Advanced Combat Engine, or ACE, is a great example where we have been closely partnering with the US Army to produce a combat engine solution that provides a significant step, a leap ahead capability when it comes to power density, power to volume ratio, among other of the critical features that the military is looking for in combat vehicles. We've learned over time the intricacies of powertrains, the intricacies of engines, and we're able to ensure that through those testing, that when that powertrain and that engine is in the field, it actually performs as it should, not on day one, but on the last day that it's on the mission. The Advanced Combat Engine, or ACE, is a new engine program that uses the opposed piston technology to produce leap-ahead capabilities in terms of packaging, power density, power to volume, and heat rejection. This translates into a lot less space required both for the engine as well as for the components that cool down the powertrain. So if you think of your cooling system, if you think of all the other ancillary systems that you need to keep the powertrain running, all those shrink in size, which allows a vehicle designer to use a space for other items that actually matter, whether you call that armor, whether you call it a defensive or an offensive system. Now that space and the weight associated with it, it's available. We are developing this engine with the US Army for their combat vehicles as their first application, but our intent is also to leverage this technology across other markets we actually operate in. Each of these type of stakeholders have slightly different needs, desires, and concerns when it comes to new product development, which requires us to tailor our approach. So in most cases, the military agencies that we work with, they represent the end users of our products. So think soldiers or warfighters, and they're always looking to provide them the best capability that they can. We like to partner with them on the development of new technologies, both at the mature end, but also at the very early stages of development. Now, switch that to, for example, a second group, which is OEMs. We typically partner a slightly different way with them. In most cases, we will work with them on technology development and be a top partner to them, but we start at a more advanced level of that development. And the reason we do that is we like to make sure that technologies that we bring to OEMs, that we bring to our customers and to our partners, we can evolve fast and we can mature in a relatively fast period so they can be used in upcoming vehicle programs. We do see tougher vehicle level requirements happening. So vehicles are going to be expected to go faster, to go to more terrains, more armor, more items that are going to increase the survivability of the vehicle. And a lot more systems are going to be demanded to be had on vehicles, and they're going to require a lot more energy out of that vehicle dedicated to those systems. So for us, what that means, it translates in not only higher power demands from our engines, but it translates into harder to get power, because these tougher requirements do not necessarily mean a bigger vehicle, right? The vehicle may stay in size, it's just the requirements of those vehicles increases. The second trend I'll mention is electrification. And I look at this from two sides. The first one, it's on generation and storage of electricity within a vehicle that can be used to power onboard systems or for any other mission. And the second one, it's propulsion. So thinking of actually being able to move the vehicle. And as we tie this into requirements, you may look into silent mobility for a vehicle. The last one I'll mention is autonomy and connectivity. The more and more we talk about robotics vehicles, we're going to be talking about how to make those robotic vehicles completely autonomous and how to balance and how to leverage the power of connectivity that has been developed into the military space to bring even higher capabilities or to enable those tougher requirements within the military vehicles. Now at Cummins, we continue to invest in our diesel, our electrified, our fuel cells, and our hybrid technologies, which are going to help us enable our OEMs as well as our end users to achieve those tougher requirements. We are leveraging the learnings we achieve from those technologies in the commercial spaces and in the over 13 markets that we actually serve, so we can also use them into defense applications. I believe diesel will still have a role to play for many years to come. I also believe that as non-diesel technologies mature, we will see them taking a more significant role in the industry. Furthermore, as we learn more about batteries as fuel cells, the hybrid systems, as well as any other fuel technologies, we will discover what the strengths of each of them are, and will end up operating in a more complex multi-fuel environment where the right fuel is used for the right application. Again, at Cummins, we continue to invest in the development of these batteries, these fuel cells, as well as other alternative technologies, because we want to stay at the forefront and continue to be the power partner of choice for our defense customers, regardless of the fuel or technology that is used in the future.